I'm going to be doing a live coding of graph connectivity, UVA problem 459. So I'll let you read the problem statement and then I'll get to coding here. So first thing, change this to main so I can submit it. Now the problem in this one is we want to find find the number of connected subgraphs. So we got to take in the input, so count the number of test cases, and then while TC minus minus is greater than 0, we have to take in the test cases. So we'll do int n, that's going to be the number of nodes, equals sc.next.char at 0. And so the E is that, so we're going to say that this is, so A is 0, and that would mean there's only one node. What we're doing here is converting the characters to integers, so it'll be easy to index them later in the graph. So next thing we're going to do, so we're going to clear the buffer, so sc.next line, that'll get rid of the next new line character. That'll be right here. And then string cur edge, so we're going to add all the edges. New or equals sc.next line, and then while cur edge dot length is greater than 1. So while we're getting edges, because it's terminated by an empty line, while cur edge dot length is greater than 1, we're going to want to add the edge. So we got to think how we're going to represent our graph. And it would make sense that we represent it as an adjacency matrix, because all we need to know when we're doing DFS is if two nodes are connected. So public static, so adjacency matrix we do with a Boolean matrix, mat. And so mat equals new int n plus 1 by n plus 1. Actually, I'm going to be doing a lot of n plus 1s all over the place. Then we'll just do plus 1 over here, make this n. And now, so we want to take in that edge, so we do cur edge. So are these, is this bidirectional or is it directional? So when we're doing our connectivity, we want to make sure that, okay, so it looks like the edges are bidirectional, so we'll do I equals cur edge 0 minus a, we want 0, and j equals cur edge char at 1 minus a. And so now we're converting these to integers again, so we can put them into our Boolean array. And so then we'll say mat ij equals true, and so that's saying if there is an edge between I and j. Then mat ji equals true, and that's saying there's an edge from j to I. Alright, sweet. So we've taken in our graph, and now we have to, we gotta do, and then that'll take in the entire graph. And then next thing we have to do is, traverse the graph and figure out how many there are. So we'll need to keep a counter for that. Here, I'll start at 0, and then let's say that each node had nothing, so we have to examine each node and count the amount of times that it's been there. So we have to see if it's been visited before as well. And so sweet. Alright. So that looks like it's good to go. And then, so now we have to visit each one of, or traverse each one of them. So 0, I less than n, I plus plus, we'd have to so if we have not visited node I, then we want to do ands plus plus, and then traverse it. So that means we're going to traverse I and kill everything inside it. So now we have to write our traverse method. Int cur node. Okay, and so how do we traverse the current node? We have to go to all the nodes it's connected to, and then mark all those visited, right? So then we go through and we'd say for I equals 0, I less than viz.length, that'll be equal to n. So we go through and we say if the current node is connected to a node we haven't visited, and not visited I, then traverse I. So then we also want to make sure that we mark that the current node is visited, viz I equals true. And then this will go through and check all the children. And if there's nothing there, it'll do a recursive call. So yeah, that should work. And after the end of that, we want to and so now, yeah, this should work. Oh, compilation error. Visited the current node.